Peter Barrett, who I'm lucky enough to call a friend of mine. Peter is Emeritus Professor at Victoria University. He's the founding director of the Antarctic Research Centre for Victoria University. Is a geologist by training, and in 1967 was the first person to discover tetrapod fossils in Antarctica, which led to understanding and an amazing amount of research on how our climate has changed, and has done a lot of work using ice core data to look into that. He's won far too many awards for me to talk to you about here, and he's mentored a whole generation of great scientists. But most of all, he's dedicated his life to understanding the changes that our climate has experienced historically, and is going, and so has great insight into the changes that we are now facing. So we're super lucky to have Peter here. Really grateful for you being here, Peter. Thank you so much. And I'm going to move this into a good location. How's this?
Okay, thank you, Kelly. Does that sound all right? Yeah, good. Yeah, well, I actually feel quite privileged to be here because I know I did a bit of pioneering over the last few decades, but I'm also reflecting on the fact that you here are pioneering now for the consequences of what we have found. And so I really want to, and encourage you to keep the Climate Assembly going and to do as much as you can, because as you'll see in a moment, it's pretty serious. Right, and first thing to say right at the outset is that while I've spent my life studying the history of the Antarctic ice sheet from a geological point of view, and in the company of many others, you don't do this sort of thing on your own, and you have to build teams, as indeed we are. You are part of a team. Well, I've also been part of a team, and the Antarctic ice sheet has gone from being stable to melting in my lifetime. But just by way of background, where I came from, I thought I'd give you an idea of my origins. Yes, a Waikato dairy farm, where that's the Kaikatea bush. That's all that's left of the original vegetation, but my dad did preserve it. It's still there. Went on from there to high school and discovered cave exploring, and I think I spent more time on that than high school, but it was a lot of fun. Then I went to university and, of course, did a thesis on the Waitomo district because it had a lot of caves in. And I think it was probably that when my roommate said, I've got this invitation from the Americans to go to Antarctica, because he'd already been, he said, why don't you go? And I think it was that persuaded them, the Americans, that I would be an appropriate person to go. Anyway, I went in 1962. I spent 3 months with 7 people who had funny accents and loved it. And we all got on well. And that sort of began my career in Antarctica. But before I go on to that, 62 was 5 years after the International Geophysical Year, where around 20 countries put bases around the Antarctic continent, and a couple in the middle. And the significance of that from our climate point of view was that they allowed observations to be made, and particularly South Pole Station began measuring carbon dioxide levels in the atmosphere. And back then, in 57, it was 315 parts per million. 315. The following year it was 316, and the year after that it was 317. So even then, people who were observant would have realised that CO2 levels were rising. Well, since then I've returned to explore Antarctica, and its geological history over 20 times, and initially mapping strata in the mountains, that recording the strata actually record being part of the Gondwana supercontinent. Deserts 350 million years ago. There was a glacial period around 300 million years ago that covered the southern continents. But then a period of forests and streams and that continued for a long time, until about 180 million years ago when Gondwana started breaking up. So Antarctica wasn't always ice covered. In fact, it's quite unusual for it to be ice covered. But then some of us in the early 70s thought, well, when did the Antarctic ice sheet begin, the current one that's sitting there? Because there's really no layers that record this on land. They've all been scraped away. And I was lucky enough to go on a drilling ship, the first one to drill in the Ross Sea, and with my colleague Peter Webb, and we found this amazing geological tool, a deep sea drilling ship. But we knew it, and that told us that the Antarctic ice sheet was old, over 20 million years old. But we wanted the detail, and so we devised our own. There was a land-based drilling project at the time, and so we sort of, the last hole of that, the 15th hole, we took the rig offshore, put it on the sea ice, and although that failed for a number of reasons, we persevered, and 5 years later we did it again, and that did better, and 5 years later we did it again, and that finally succeeded. So we developed this technology, and I've got to mention here my colleague Alex Pine, who was the technologist that actually did all the hard work to make these things work, into a series of drilling projects that gave us this younger history of the Antarctic ice sheet itself from what the glaciers were carrying offshore as they advanced and retreated. So essentially this led to our knowledge of what we now know about the Antarctic ice sheet over the last 34 million years. It actually first formed 34 million years ago. And this is a simple geological story or a graph, and I've drawn it this way with time oldest at the bottom and today is at the top, because that's the way geologists see things, and that's the way drill cores work. The oldest is always at the bottom. And what you can see there is that the Earth was pretty warm in the lower half, at least until around about 30 million years ago. No. And then there's quite a dramatic cooling, or 34 is the actual number. And our drilling had actually demonstrated the ice sheets going back and forth from that time, all the way up through to, to the present day, except that it became super cold in the last couple of million years. And one of the features that we know from the geology is that the Antarctica was actually, and the Arctic were tropical 50 million years ago. And that was when Earth was around 12 degrees warmer. And so we've really only had this ice sheet for 30 million years or so. But now it's starting to melt. And one of the issues with that is that the whole Antarctic ice sheet actually has 57 metres of sea level equivalent in it. It's not going to go right away, but once it begins, it'll be hard to stop. So, but it's one thing for geologists to be able to do this and say it and report it. It's another thing for people to get people's attention. And it was really in the 1990s that satellite measurements started to show that Antarctica really indeed had begun to melt. We could observe in the Antarctic Peninsula that ice shelves were breaking out. So now it's actually far more well substantiated, and there are climate modelling shows without any doubt, based on geological data for testing, that the climate is indeed changing, and not just through melting Antarctica, but the more extreme, the greater extremes of temperature, of storminess, and yeah. So it's hard for me to understand how climate denial has taken hold, and especially in corporations and sometimes even entire country leaderships. I mean, we now know that Shell oil scientists in the 1980s advised their managers of the consequences of the continuing use of their project, and this led to a campaign of denial and misinformation by the major oil companies. And this is no secret. Naomi Oreskes wrote a book about it called Merchants of Doubt. They followed the same approach as the tobacco companies when they found that their product was dangerous. But I think, well, the scientific point of view, not me personally, is that the solution to the problem is pretty straightforward. It's reduce carbon emissions to zero, there's no ducking it, and there are opportunities to sequester carbon in various ways from the atmosphere, take it out of the atmosphere where possible. You've probably been reading about crushing up dunite and distributing that. That's got quite a cost to do it on scale, but kelp farming is another way that's being investigated. It goes on, but the best way is to not put it in the atmosphere in the first place. Essentially, carbon has been sequestered naturally over 200 or 300 million years on average, and we've been putting it back up there in decades. So communities everywhere need to address this, and it's great that you're doing it here in Porirua. Ongoing climate denial by corporates and governments presents a huge challenge to convincing people that the problem is real, especially when it requires investing in protecting society rather than making future profits or further profits. So, let's see. This is a graph that really, to me, as I was working on it this morning, increasingly shocked me, because I was born, I can't use the point, but I was born down when global population was around 3 billion years. You can see in the black line. And as we move up, you can see that CO2 level has been rising 350 around about 1992, the first IPCC report. Then, but today it is now 420 parts per million. When I first went to Antarctica, or the first records from Pole Station in '57 were 315. And it's been accelerating just in the last few years, and you've probably read that in the last couple of years, Earth's average temperature is now 1.5 degrees Celsius above the background level, and there's no sign of the curve flattening out. Well, I guess what I need to, in fact, what I did, was it 10 years? Yeah, 10 years ago now, because no one was, I thought, listening to my papers, reading them, doing anything. But not just me, my fellow scientists. There was a conference in Wellington in 2006. Jonathan Boston ran it, Climate Change and Governance. It was at a time when climate change was on the cover of Time magazine, so we thought, we've got to do something about this. We've got to do more than just write papers, talk at conferences. We've got to make a film. And so my friend Simon Lamb and I did this, and It's called thin ice. It's in the resources there.